Have you ever gazed up at the night sky and wondered about the mesmerizing dance of the stars? Prepare to embark on a journey through the awe-inspiring mysteries of the cosmos, where every twinkling light holds a story waiting to be told. In today's thrilling adventure, we're diving deep into the heart of space science, unraveling the enigmatic workings of stars and the forces that shape our universe. From the fiery depths of the sun to the farthest reaches of the galaxy, get ready to witness cosmic phenomena like never before. But before we blast off into the cosmos, let's unravel a celestial conundrum. Why doesn't the sun collapse under its own gravity? Join us as we uncover the ingenious mechanisms that keep the sun shining bright, illuminating the vast expanse of space with its radiant glow. As we journey through the cosmos together, we'll explore the fascinating interplay of gravity, radiation, and stellar evolution, uncovering the secrets of the universe one discovery at a time. So, fellow cosmic adventurers, buckle up and prepare for an exhilarating ride through the cosmos. And don't forget to hit that subscribe button to stay tuned for more captivating space-related content. The universe awaits. Let's dive in and explore together. Stars are some of the most beautiful and awe-inspiring objects in the universe. Through violent thermonuclear reactions, they emit enormous amounts of light, illuminating the night sky and heating up any nearby planets in the process. Through mergers and powerful explosions, stars are also responsible for producing the heavy elements that make up much of the matter we see around us. Astronomers and astrophysicists have come a long way toward understanding how stars operate, to the point where we can even predict how long it will be before our sun runs out of fuel and transforms into a red giant. But today, we're not just going to talk about the types of stars we're familiar with. Instead, we're going to contemplate stars we've never seen before, ones that astrophysicists say could hypothetically exist, including ones that are quite literally made of vacuum. Some of these stars can mimic black holes and resemble dark energy, which is why they have been the subject of many recent studies and even some sensational drama in the world of physics. In this video, we're going to explore all of it, from the physical theories at the core of these ideas to the wildest speculations surrounding them. First, we need to lay some groundwork and understand how stars work in general, starting with the most important star of all, the Sun. For our Sun, the pressure comes from fusing hydrogen into helium. When the Sun runs out of hydrogen in about 5 billion years, it will become a red giant star, whose pressure comes from fusing helium into even heavier nuclei. Eventually, the Sun will also run out of helium and any other light elements that could be used as fuel for nuclear fusion. At that point, it will collapse into a small star known as a white dwarf. Since no more fusion is occurring anymore, white dwarfs are sometimes called stellar remnants instead of stars. But if there's no more fusion, where does the pressure to support these stellar remnants come from? It turns out that gravity pulls the gas of a white dwarf inward until it's so dense that a new type of pressure emerges, known as electron degeneracy pressure. This is a purely quantum mechanical effect, and it's the same effect that's responsible for you not being able to pass your hand through solid objects. Electrons simply cannot get too close to each other without an extraordinary amount of energy. But some stellar remnants are so massive that even electron degeneracy pressure isn't strong enough to counteract the pull of gravity. This is called the Chandrasekhar limit. It's absolutely impossible to have a stable white dwarf any heavier than 1.4 times the mass of the Sun. If a star has burned through all its nuclear fuel and its core is still heavier than the Chandrasekhar limit, that core will collapse in on itself until it becomes so dense that an even stronger type of quantum pressure emerges. known as neutron degeneracy pressure, which, as you may have guessed, prevents neurons from getting too close to each other. A star that reaches this state is called a neutron star, the smallest and densest known class of stellar objects. So now you might be wondering, is there a maximum mass that a neutron star can have while still being supported by neutron degeneracy pressure? And there is. This time, it's about 2.2 times the mass of the Sun. Any heavier than that, and the neutron star would keep collapsing under the influence of its own gravity until, well, actually, not until anything. As far as we know, neutron degeneracy pressure is the strongest possible pressure that ordinary matter can exert, so there's nothing left to prevent a sufficiently heavy stellar remnant from collapsing in on itself forever. You might think that we could just continue the pattern that we were starting to see earlier. Stars could get even smaller and even denser than neutron stars, as long as they were supported by some even greater pressure. You might think that the only limit on how small these stars could get would be the point of no return, where they would turn into black holes. That point of no return is when a star becomes smaller than its own Schwarzschild radius. This is almost true, but not quite. Instead, physicist Hans Adolf Buchdahl showed in 1959 that a star made of any realistic form of matter with positive energy density and pressure can't be smaller than 9/8 times its Schwarzschild radius. It might not sound like a big difference, but that factor of 9/8 means that any realistic star has to be noticeably larger than a black hole, making it much easier to tell them apart. That's when physicists began asking about stars that Buchdahl would call less realistic. As we conclude our cosmic journey, we're left pondering the mind-bending mysteries of the universe. From stars that defy conventional limits to enigmatic objects that challenge our very understanding of space, the cosmos continues to astonish and intrigue. Consider the tantalizing possibility of stars crafted from matter that bends the rules of physics, where negative pressures coexist with positive forces in a delicate cosmic dance. These exotic stars, while theoretical, spark endless fascination and debate among astrophysicists, blurring the line between reality and imagination. Yet, amidst the cosmic chaos, one thing remains clear: our quest for knowledge knows no bounds. Each discovery, each revelation brings us closer to unraveling the cosmic tapestry that surrounds us, painting a picture of the universe in all its complexity. Remember to hit that subscribe button and journey with us as we navigate the cosmos together. The universe beckons and the mysteries await. Until next time, keep gazing at the stars and dreaming of the infinite possibilities that lie beyond.